start from 3D buggy house this time. And of course, we got the buggy house. It's so buggy. Control U takes you to the source code. First off, I want to try and, again, disable everything as much as I can. Get rid of all the pillars. Okay, no door anymore. And it's still buggy. This is what I'm most worried about right here.
The floor and wall should be perfectly connected, but as I look around, a gap forms between them because the lines are distorting differently from each other.
It means that there's something wrong with the way that I'm distorting the lines, and that might not be the easiest thing to fix.
Now I'm getting rid of the roof.
Okay, we have no roof. Apparently we still have a ceiling because somehow the sky turns into the ceiling. That's buggy. When I only draw the floor, yeah, we get problems. Look at the way that it's moving away from me. But more importantly, if I look up, the entire sky becomes the floor. Now, when we decide to look up, what happens? At the point where they go off screen, they still haven't gone behind us. And yet, look at this rising up above us. It takes a long time before they both actually go negative, at which point we then lose it.
So let's say these AirPods are our player and this remote is our polygon. When the player looks up, the polygon moves relative to them like this. At that point, the poly's front two vertices are below you while the back two are above you, so when filled in, it covers the whole screen.
So this naive approach of draw the polygon if at least one of the points is in front of you doesn't really work anymore because this point's in front of us and yet this point has crossed over to the top. Let's say this is the side view, this is the screen, this is the player. Well, if a polygon goes through the screen and off screen, maybe what I could do is I could just take that intersection point where it goes through the plane of the screen and then make calculations to that point. And so in order to do that, we have to know the plane of the screen. And the thing about planes, as we already know, is that the dimensions of any vector that's perpendicular to it are the a, b, and c coefficients of that plane. And the vector perpendicular to the plane is just the direction that the player is looking. So then we just have to find which direction is the player looking. So here's a side view. We do some math to find y, and we assume that the direction that the player is looking has a length of 1. And then from there, we can find the y component. And then from what's left over, which is, if we take sine of the angle of the y angle to get y, then cosine of that is the other hypotenuse. And we can take the sine and cosine of that to find the x and z components. And then that should be a normalized vector. Our y-ang is fp y-ang. We do math.sine of that angle, and that's our y component. The xz components would be the cosine. I think this is wrong about which one's x and which one's z here. I think cosine would be x, so let me do that. Right, then we just multiply that by the xz comp. And then the z comp is very similar. I'll just call it the look vector. Then from there, we use the x, y, z coordinates to get d. So here's the 5 different ways that we can draw a polygon with respect to the screen. Here, this polygon is entirely in front of the screen, so we don't care about that case. And here, all the points are behind the screen, so again, we don't care about that case because we just don't draw that polygon. So we've got a scenario where there's 3 points in front of us, a scenario where there's 1 point in front of us, and a scenario where there's 2 points in front of us. With the 2 scenario, we just take these 2 vertices and we find where their line intersects with the screen, like so, and basically that becomes our new polygon. So for this polygon, it's also pretty similar. For these 2 points, we find where they intersect with the screen, and we draw them and we get rid of them. But where does this point go? Well, it could just be anywhere. We'll just set it to be, I don't know, the left point maybe. So then there's 2 left points that are at the same spot. But this guy is probably the hardest, because you'll notice that 3 points have already been used up on this side, and then to draw it properly, we actually have 5 points here. So to draw this right, we'd have to make a pentagon. So instead of doing that, because screw that noise, so I guess what we could do is we can take these 2 lines, we can use them in 3D space, and then when we're done, we'll be left with 2 lines in 2D space, right? These ones right here in 2D space. From there, we can find the intersection in 2D space, and then draw the point down here, so that way it remains a 4-sided polygon. I don't know, that might work. We're going to just iterate through each of the points. And if it's a negative point, then we check to see, are the points adjacent to it?
Are those negative? And there's 3 different scenarios. They could be both positive, in which case it's this scenario. They could be both negative, in which case it's this scenario right here. Or they could be one positive and one negative, which could be right here, right here, right here, or right here. I'm going to change do draw though to positive z's. So I could just say pos z's plus equals that and get rid of this commented out stuff because that's irrelevant. If we have no positive z's, we just stop. But if we have at least one negative z, which would be what, qd.length, less than that, then this is where we got to do that conversion process. So now if qdi2 is less than 0, so it's negative, then check the other two. So that would be qdi plus 1 mod qd.length. And the other one is I plus qd.length minus 1 mod qd.length. Right, those are the adjacent points. We have to test those. So we say less than 0. So if prep point, next point, if they're both true, if they're both false, else one is false, the other is true. Let's handle that one first because it's easiest. So at this point, we have to get the vector of those points. And I'm going to need these x, y, z points again, so I'm going to put this into a better structure. So now I can reference that. You know what I'm going to do is I'm going to take this out. I'm going to call this prev idx. Same with this too. Next idx. Then I can just use those. Right, so the else condition, which is this one, we're trying to find this point. I'm forgetting the 2 in here. That's important because we're testing the z value and that's where that is. So in this case, we only care about the positive value, so we need to know which one's positive. So then we do qd 3d of our use idx. We subtract qd 3d of our I of 0. So those are the x diff. So repeat that for y and for z. So this x, y, z diff is our vector now. What's the formula for finding the intersection of a line and plane again? I forget already. Here we go. All right, let me just copy this. Okay, so now I can call the screen plane function. That will give me ABCD. There, that gives us our t value. So then what do we do from there? Well, let me just copy all of this. And now we have a point. Then what do we do once we have that point? I think we just get 3D point again on it. And then that'll set the new points to be what they are. Okay, but that's just the simplest scenario. What about where both points negative, right? This situation. Well, then it might as well be that that point doesn't exist. Because I don't know what else to do, I'll just set it to -1. I could say something like, if new points of I is -1, if that's the case, we could just set it to whatever the next one's point is. Alright, so that handles that case. Now this case, oh god. That makes me want to functionize this, so I don't have to write it again. Alright, there, it's been functionized. So how does this work? Get intersection point, we give it screen plane, we give it point 1 and point 2. Point 1 is QD 3D of I. Point 2 is QD 3D of use IDX. And then that gets us the intersection point. And drop all this code out. So then we have to find 2 intersection points in this case. Intersection point 1. But in this case, yeah, we don't care about use IDX, we care about prev IDX and next IDX. So we do both of them. We get 2 new 3D points, and now that we got those 2 new 3D points, we have to do a line intersection. In case it's not clear, right now I've found these 2 points, and so I want to find this line and find out where they intersect in 2D space. Because wherever that new point is in 2D space is where we're going to assume where we draw it to the screen. We say QD of prev IDX minus n1 of 0. We get an x difference, and then that's our slope. Right, so I did some math. Let me just put it out into code now. So the x coordinate of the return value is that, and the y value, and then return the ret. Do a line intersection 2D of n1 and qd prev idx, n2 and qd next idx. There. Okay, and then I could go and test this to make sure it works. So after extensive graphing, I realized some things. So this is the new screen plane function. I'm not even sure what all the things are that I changed. I kind of just kept graphing until it worked. But even then it actually didn't work because trying to intersect at the 0 point basically results in you dividing by 0. So instead I add 1. So if anything is 1 unit away from your face, then it's considered
behind you. And that worked for all but one of the cases. But in the one case where 3 points are in front of you and 1 point is behind you, this happens, where when trying to find the intersection point, it just jumps to the other side of the screen. Now, these lines on the left and the right side, I put them in for debugging purposes, but from them, you can sort of tell what's happening. Just pay attention to the 2 lines on the bottom here. Notice how they're becoming less and less sloped, and then right at 0, they're almost straight up and down, and then they flip, and if you look at the lines now, they're kind of going in the other direction. So that's why it ends up that the intersection point is on top. So even though it doesn't seem to make sense that that would be the case, that is what's happening. And what essentially that means is that there is no single point that you can connect to that would be accurate for both lines, because they're going in opposite directions, which meant that I needed to be able to graph a 5-sided polygon. So down here, instead of doing draw quad, I created a new function, draw polygon. Draw quad was just taking in 4 hard-coded points, but draw polygon is better because it can just handle any size polygon. And with that, I now have this working consistently in some fashion. It is weird when you think about it that these 2 lines on the left and right side are never going to collide with each other, that the shape of the floor distorts that much. If I look up, this doesn't appear above me, right? Yeah, good, okay. So maybe I fixed it. I sure hope so. Yeah, you can see all of the different ways that I was trying to implement this and they didn't work. All right, let me put in some more polygons. Looks about normal. So I uncommented out the whole draw house function. Okay, yeah, it's still having a few problems, but it's less problems than before. What happened to the door? Why did the door disappear? Why is this like flat against the wall? And then yeah, sometimes just this wall disappears. Why does this wall disappear? Whatever, it's been like 3 weeks or something since I put out the last video, and alright, I'll figure out why this is wrong, because I fixed something at least. I'm not getting the weird issue from before where the wall was splitting away from this polygon, you know, it's actually being consistent. It's just now the sorting algorithm or something is going wrong. And also, for some reason, the door is not being drawn. I don't really get why, but it's not. So, whatever, I'll fix it later.